Okay, so I'll put the camera on me. And we'll get recording. Gonna give you some practice on the quadratic formula. I have a worksheet for you there. I also will bring the worksheet up online. We'll work through these practice problems and then maybe go back through chapter 2-4 in the textbook to help you with any of that. So let me bring the quadratic formula up online here. Let's see here. I'm gonna go there. That's the only thing kind of hanging on. It's just a little frog in my throat. Otherwise, I'm feeling fine. That was a long 2 weeks in the living under a rock, living in my basement. Question.
Which lesson are you in? Are you on 2.6 or 2.5?
It's 2.4. Let's check. Because I get different numbers depending on where I look. Week 5, 2.4. Week 6, we'll be getting into week 6. I'm going to make sure we understand 2.4, the quadratic formula. We're going to make sure we got a good handle on the quadratic formula. Then we'll also can get into 2.6. Okay, so here is the worksheet that you have. And I'll grab my pencil and get ready to do this, but I want you to start on it first. And well, let's see. We have this. We need to practice the song. Now, just in case you want some extra credit, you can get extra credit by performing the song, the quadratic formula song. If you have a desire to perhaps one day be on America's Got Talent or The Voice, this could be your start. And it goes like this. Well, we should probably draw it out. I don't have a marker here. You could even sing it while you're drawing it out. I mean, it could be that exciting. So it goes like this. In the quadratic formula, you could introduce the quadratic formula song. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That song should bring back memories from your childhood. Cranking the little knob on the little box. You remember that?
I'm doing that. I hope I pass the whole class.
Goes the weasel. If you can perform this, I'll definitely give you extra credit. If you can remember that formula, well, that's what the song is for, to help you remember that formula. In my geek life in high school, I would derive this on the chalkboard, trying to impress those girls. Not kidding. That's what I would do as a geek. Derive. You can derive the quadratic formula starting with ax squared plus bx plus c equals 0. You can go through a few formulas and come to this, and it actually only takes about maybe 5 lines in the formula. Not going to do it right now to impress you, because we just want to remember that. You don't have to worry about deriving that. That's a fun part that the geeks love to do. But remember the song. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, in the homework that I give you here, or in the practice we're going to do today, I say solve the discriminant first. What's that discriminant? That's this part under the square root. That's our discriminant. Because if this is positive or negative, or 0, it will determine how hard a problem this is. Can you imagine if b squared minus 4ac is 0, all you have to figure out is negative b over 2a. That's a lot easier to solve than b squared minus 4ac. So if you solve this first and you find this is a negative number, you can right away say, wait a minute, square root of a negative number, that's not a real number, it's an imaginary number. So I know I'm going to get imaginary solutions. So if it says, if it's not a real solution, just say imaginary solution. I don't have to do any more work. So we'll do this discriminant first as we look at these problems. But we've already got a problem. It's not in the form of ax squared plus bx plus c equals 0. It has to be in this form in order for me to be able to use the quadratic formula. So we have to put it in this form, and then we'll know what a, b, and c are. And if we know what a, b, and c are, we can just plug it in to the quadratic formula. That's the nice thing about the quadratic formula. It's just a brute force. If you don't know how to the factoring doesn't jump out at you, you don't see the obvious factoring, we just say, well, put it in this form, crank it through the quadratic formula function, and I'll have the answer. Okay, so first thing we have to do, we have to get it in quadratic formula form. So how are we going to do that? We need x squareds plus so many x's plus the constant on one side and 0 on the other side. Well, it looks like the easiest way to do it is to subtract 8x squared from both sides. So let's do a minus 8x squared and do a minus 8x squared here. And so then I'll get a 0 on this side. And what do I get over here? Well, a minus 8x squared plus 2x squareds gives me a minus 6x squareds. And then I have a minus 3x and a plus 6 equals 0. Now, if you don't like that negative in front of the 6, you can always multiply everything by negative 1. It's perfectly legal to say, wait a minute, I don't like those signs. Let's make it 6x squared plus 3x minus 6 equals 0. You're perfectly allowed to multiply everything by negative 1 because 0 times anything still leaves a 0. So it's valid to do this as well. I also see one more thing, that there's a factor of 3 everywhere. Why not make it simpler by dividing everything by 3, just to make smaller numbers? It's not absolute. I could use the quadratic formula right now and still get the right answer. But just to make my life easier, let's divide out the 3. So that becomes, so divide everything by 3. That gives me 2x squared plus x minus 2 equals 0. Now I have it in simpler, smaller numbers, ax squared plus bx plus c format. Now I can calculate the discriminant as I plan my quadratic formula. And just for practice, I'm going to sing the song and write the formula one more time. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that little clown popping out of the box brings cold sweat to your mind, or joy and delight as you remember that childhood song. If you don't remember that childhood song, you have a deprived life, and you need to go learn the Pop Goes the Weasel song. Okay, discriminant time. Well, what is A? A is 2. B is 1. A equals 2, because that's multiplying x squared. B equals 1, it's multiplying the x. And C is negative 2. All right, the discriminant is b squared minus 4ac. All right, b squared minus 4ac is equal to, well, b squared is 1 minus 4 times, and let's be careful, 4 times 2 times a negative 2. This is an easy place to fall down and mess up. Remember, you're subtracting a 4 times 2 times negative 2, which is you're subtracting a negative 16, or you're adding 16. So that is equal to a positive 17. It's so easy to say, wait a minute, 4 times 2 times 2, that's 16. 1 minus 16 gives me negative 15. But you forgot you're subtracting a negative 16, which becomes an adding. So put parentheses around 4a and c whenever you have not all positives in there. Just watch those signs. Those signs, the negative sign will throw you off. It's so easy to be thrown off by that negative sign. And it looks like, wait a minute, I'm going to be getting a negative number. No, no, no. You got a 17 there under the square root. So now that we know that it's 17, well, I know that b squared minus 4ac, there's going to be that square root of 17. So let's go ahead and do the full formula now. X is equal to negative b, that's negative 1, plus or minus the square root. Well, we've already calculated b squared minus 4ac plus or minus the square root of 17 all over 2a. A is 2, and so it's all over 2 times 2, all over 4. Now the question is there any way to simplify that? Well, 17 isn't anything squared. 17 is a prime number. There's no factors of 17, like a 4 times something. No. So I leave it as square root of 17. Unless they ask you to use your calculator to calculate it, you are done when you come to here. If you want to be very explicit, you could say x is equal to negative 1 plus square root of 17 over 4, or negative 1 minus square root of 17 over 4. I'm happy with this. Just say negative 1 plus or minus square root of 17 over 4. If either of these comes out to be, a nice whole number, it's nice to list them out. Like I got a 3 and a 5, rather than 1 plus or minus 2 over 4. But you'll see, if this doesn't simplify, this is an easy enough place to leave the answer. So let's review how we did it. First of all, we wanted to put it in ax squared plus bx plus c format. I can adjust the signs to make it a little fewer negative signs to deal with. And I can divide by common factors to make the number smaller. And then start there, as that's my a, b, and c in my ax squared plus bx plus c equals 0 format. Once I get this far, now it's just a matter of cranking out the quadratic formula. Does that make sense to you? Now, working it through by hand will help you to understand it and be able to do it on the quiz by working through by hand. So I'm going to give you a chance to start on this one, and then I'll start working through it. If you didn't get anything in this first one, let me know. Otherwise, start on this one. And I'll get started in about a minute. But give you a chance to work ahead of me. And as I go through it, you'll be confirming, are you doing it the right way. Oops, accidentally. Remember, you want to get an ax squared plus bx plus c format first. Okay, I'm going to get started on it. Follow along here now and see if you've already figured this out. There's no common factor, but I want to get the 3 over on this other side. So I'm going to subtract 3 from both sides. And since the c, I like to put the c as the third thing, I'm going to do subtracting the 3 right there. So this becomes 5x squared plus 4x minus 3 equals 0. Now I'm ready to crank out the discriminant, and then we'll worry about the rest of it. So let's put it right here. The square root of b squared minus 4ac, or what is b squared minus 4ac? That's the discriminant is what's inside the square root. So b squared minus 4ac, let's see here, is equal to, well, b is 4, right? This is a, b, and c is negative 3. So b is 4, so it's b squared is 16 minus 4 times 5 times a negative 3. So that becomes a plus 20 times 3, right? 4 times 5 is 20, times 3 is 60. I'm subtracting a negative, so I'm adding a 60. So that is equal to 16 plus 60 equals 76. It's a positive number. Let's see, it's 38 times 2 or 19 times 4, right? And square root of this will give me, well, the 4 becomes, square root of 4 becomes 2. Square root of 19, well, 19 is prime. So if I take the square root of that whole thing, I'm going to get plus or minus 2 square root of 19. If I take the square root of plus or minus the square root. So the discriminant, I could stop right here, is 76. So I know I'm going to have a real solution, 2 possible answers. It's not making it easy, but I'm not getting an imaginary solution because the discriminant is positive. And this is just extra to make it easier when I get to that part about plus or minus the square root. I know it's going to be plus or minus 2 square root of 19 because 76 is 4 times 19, which is 2 squared times 19. And the square root of 2 squared times 19 is the same as 2 square root of 19 because 2 squared square root of is 2. That's how that becomes plus or minus 2 square root of 19. So now, quadratic formula. X is equal to negative b, negative 4, plus or minus the square root, and we've done all that, so I know it's plus or minus 2 square root of 19, all over 2a, and a is 5, all over 10. Well, I have a factor of 2 here that I can factor out. Is 4, 2, and 10 are all factors of 2, so that can be then simplified, reduced to negative 2 plus or minus square root of 19 all over 5. There I have quadratic formula solution. Don't have to worry about, I could put that into my calculator to get a plus or minus and find the two numbers, but this gives me the complete perfect answer without having to even use my calculator. Just throw in, well, it's quarter to 19. We can't simplify into something smaller or simpler. We did reduce the factors of 2. You might get partial credit for not reducing it, but you'll get full credit. Reduce any fractions, common factor of 2, get rid of that, and you'll have the answer using quadratic formula. So there's your second practice problem. Remember again, you want to get it into the ax squared plus bx plus c equals 0. Got to get it into that form if you want to be able to use the quadratic formula. Without the 0 over here, you're solving a different problem. So make sure that you rearrange things first, and then you're ready to crank out the discriminant and then the final answer. You know what? I'm going to do the next one in a different color just to make it easy to see which ones are different. So I'm going to change to just a little purpley. We'll go dark green now for this next one. Yeah. Okay. It looks close to the other one, but we never know. It's only 3, 4, and 5s, but they're in different places. It looks like all we got to do is subtract 5 from both sides. So let's do the 5 subtracted from there because that's where the c is. So it becomes 3x squared minus 4x minus 5 equals 0. That, and there's no common factors of 3, 4, and 5 that I can divide out. I could multiply by -1 if I like a negative in front of the 3 and positives in front of the others, but I like it this way. Let's go with that. So now let's do the discriminant. This is A, this is B, this is C. B squared is -4 squared minus 4 times 3 times, oh look again, a -5. And that's the same number we had before. That becomes a plus 60. Oh look, we're almost getting the same answer. How could this be? Let's find out. Negative b is different. We've got a -4 instead of a +4, but otherwise it's looking b squared minus 4ac is going to give us the same number, right? B squared is 16 minus 4 times 3 times -5 is the same as plus 4 times 3 times 5, which is 12 times 5 is 60. So 16 plus 60. Oh, we got the same discriminant as the previous problem. We have 76. So I know there's going to be a square root of 19 in my solution, right? Because that we know is 76 is 4 times 19. Okay, now we know the discriminant. Yeah.
Why do you do that? Why do you break it up?
Just to give us practice, because knowing if b squared minus 4ac, if we know we're going to be taking the square root of that, if that number is negative, I'm going to have a square root of a negative number, and that's an imaginary number, so it's not a real solution. If that comes out to be 0, then I know I have a real simple problem. But it's one way of looking at the problem of, hey, let's look ahead. What's going to be taking us, what are we taking the square root of to know whether, you know, I might, if it's negative, that's the main thing. If I see, hey, my discriminant is negative, I can say, wait a minute, there's not a real solution. I don't need to go any further unless they say, show what the imaginary solution is. But if they say, show the real solution, and you come and realize this is negative, you can right away say, there is no real solution. There's a negative inside there. I know it's going to be 2 imaginary solutions. So that's the reason they like to look at that discriminant. It does make it more mathematically interesting. Can do really cool things with imaginary numbers, but that's not algebra. That becomes complex mathematics. We'll leave that to the next level of mathematics. Okay, now crank it into to the formula. X is equal to negative b. That's a negative of negative 4. So let's just go ahead and do that. Negative b plus or minus the square root of 76 all over 2 times a, which is 6. All right. Now we see that there's a factor of 2 there. Well, we know there's going to be a factor of 2 there, but let's do it in 2 steps. So negative of negative 4 is 4 plus or minus, well, we know the square root of 76 is 2 square root of 19, because we've done that up here with square root of 76. Square root of 4 times 19, all over 6. Now let's go and factor out the 2 to reduce. So it's 2 plus or minus square root of 19 over 3. So similar form and a square root of 19 in there, a negative 2 and a 5 under that one. A 2 plus or minus square root of 19 over 3 for this one. So even with 3, 4, and 5 in there, I'm not quite getting the same answer, which makes sense. I don't have the same formula. I should get exactly the same answer, but it's similar numbers. That square root of 19 likes to show up in there. All right. So we'll go back to our different color to discriminate there. All right. It does get a little fancier, a little more difficult than that last one. This one here, though, it's about the same. Let's see if we can get this one again rearranged to get into ax squared plus bx plus c format. 3x squared. Well, I subtract 4x from both sides. I add 5x to both sides. I add 5 to both sides. And that leaves me with 0 on the right. So I did a plus 5 on both sides. And I did a minus 4x to both sides. So I get to get my 0 on the right. And then arrange these nicely to now have ax squared plus bx plus c format. A is 3, b is negative 4, c is 5. So just to pre-work the discriminant, well, b squared minus 4ac is negative 4 squared minus 4 times 3 times 5. And there's a positive number in front of the 3 and the 5, so it is a minus 60. So it becomes And I remember it's -4 squared, so that becomes 16 minus, again, that's 12 times 5 or 20 times 3, 16 minus 60 is equal to -44, right? Now I know that that's 22 times 2 or 4 times 11. Or 4 times -11. But knowing it's a negative number, I know that I'm going to have imaginary number solutions. Well, it didn't say here, throw it out if it's imaginary, but at least we know we're going to have a weird answer, 4 times 11, or when we get to the square root part, it's going to be interesting. So we know right away we're going to have imaginary number solutions. Well, let's now crank the formula using the values of a, b, and c. X is equal to -b, -4, which is 4, plus or minus the square root of -44. All over 2a, which is 6. Well, I know what -44 is 4 times 11, so that's going to be equal to 4 plus or minus 2 square root of -11. Well, this any square root of -1 we know is the imaginary number I. Well, let's first factor out the 2's, so that becomes 2 plus or minus I square root of 11 all over 3. Because the square I is defined as the square root of -1. That's that imaginary number that whenever we have a square root of a negative number, we're going to have I in there, our imaginary number I. And we don't have to simplify any further. We know that we have 2 imaginary solutions. We've reduced it, 2 plus or minus I square root of 11. A weird imaginary number, but we use the quadratic formula to find it, cranking through the quadratic formula. And since we use the quadratic formula, we can be confident we have the right answer. Now, if you ever wanted to, you could check it by taking 2 plus I squared of 11 over 3, plugging it into here and doing the square root, and you should find that it will solve to be 0. But I'm not asking you to do the check your answer. That's for your own recreation. Now the last one. Choose a different drawing color, just for fun. Bring that closer to the top of the screen. I want to, let me bring it to the top of the screen. There we go. Well, first, it's all that rearranging. Now, unless there's fewer things over here, I usually go with subtracting things out from the right side and bringing them over to the left side. And it looks like that'll work here. So subtract 2x squared from both sides. We'll get rid of that. Subtract 3x from both sides. We'll take that away. And add 4 to both sides. and that gives me a 0 on this side. So now let's do 4x squared minus 2x squared. That gives me 2x squared. Minus 3 and minus another 3 gives a minus 6x. Plus 2 and a plus 4 gives me a plus 6. Equals 0. And just to make our life a little easier, let's factor out that leading 2. X squared minus 3x plus 3 equals 0. Now, I don't see two numbers when multiplied give me 3, when added give me negative 3. So I could right away see, well, maybe it's easily factorable. Well, it doesn't seem to be. Let's see if the discriminant verifies that. Let's do the discriminant. We'll do it over here on the right. B squared minus 4ac is equal to, well, b is negative 3, so negative 3 squared minus 4 times a is 1 and c is 3 minus 4 times 3. All right, that's a minus 12. So that becomes 9 minus 12 equals, oh man, a negative 3. That's why I don't see an obvious factoring, because a square root of taking a square root of that's going to give me an imaginary number. So another imaginary answer, because I know what's going to be under the square root will be negative 3. My discriminant is a negative number. Just to verify, b squared, 9, minus 4ac is minus 4 times 3, minus 12. So, yeah, 9 minus 12. Whenever you get that, it doesn't hurt to go back and check. Did I mess up on any signs? 4ac, a and c are both positive, and I'm subtracting 4 times those. Nope, didn't make a mistake. I'm getting a negative discriminant. So plug in the formula. X is equal to negative b, that's 3, plus or minus the square root of negative 3. All over 2a, a is 1, so all over 2. Well, the only thing that I can simplify is the square root of negative 1 times 3 is I square root of 3. So that becomes 3 plus or minus I square root of 3 all over 2. Can't simplify it beyond that. You can't take any, start dividing by 3s. Don't be tempted by that, although you see 3 at top. They're different. That one's a square root of 3 and one's a 3. There's my answer. Cranking it out through the quadratic formula. So although it looks like, hey, that ought to be very solvable, really simple quadratic formula. You'd think that would come out with a real numbers, but no, there is no real solution to that. One way to look at that is go to my favorite website for algebra, geogebra.com, and start a calculator. I don't even need to sign in. And I can plug in x squared minus 3x plus 3. And let's see what that looks like if I graph it. I just type in up here x caret 2, right parenthesis, what is it? Minus 3x plus 3. Minus 3x plus 3. And I see that that's a curve that never hits 0 in what I'm looking at what that curve looks like in real life. In graphing that curve, y equals x squared minus 3x plus 3, it never hits 0. Therefore, the answer to when is it equal to 0 never gives me a real solution. I'm mapping it in the real number plane. I can see it never crosses 0. That's one way to think about this, is just graph that curve and think about when I'm looking at this, that curve setting equal to 0, I'm basically looking for where does it cross the x-axis. Graphing it shows me, oh, it's never going to cross the x-axis when I have real x and a real y. Maybe in some imaginary world that the mathematicians are happy to make up that's coming out of the screen. That's a whole different world of numbers. And it's a very interesting world of numbers, but not real. So that's why, another way to see why that never gives me a real answer, only an imaginary answer. Same thing with 3x squared minus 4x plus 5. Let's graph that. I can come over to GeoGebra and just say 3x caret 2, right parenthesis, minus 4x plus 5 minus 4x plus 5. Enter. That's the red curve. And I see again that red curve. I'm always adding 5. That kind of makes sense. If I add 5 to it, it's never getting low enough. Even when x gets really small, it's always added 5 to it, so it's above the x-axis, never crosses it. So there is no solution to, is it equal, when is that equal to 0? There is no solution because the graph never crosses the x-axis. So when you're looking at that quadratic formula, whenever you have ax squared plus bx plus c, sometimes it's not going to cross the x-axis. Let's do that just for fun. Remember how we can do that in GeoGebra? I can type A, hit enter, B, hit enter, and C, hit enter, and then give the formula ax squared plus c, and I can erase the other lines for now. And as I adjust A, B, and C, A gives it a steepness to my curve. I'll zoom out a little bit. A is what makes that curve either go up or down based on the sign of A. B adjusts the behavior around the y-axis. And C moves that up or down to know whether or not it ever does cross the y equals 0 axis. So that's the effect of C, raising it up and down. The effect of B, kind of how it behaves around the y-axis. And C, how steep the curve is and is it going up or down. Great place to play with visualizing these functions. So say there's a curve. I can make it never hit the x-axis by adding a 5 to it. Adjusting b a little bit, maybe make it cross if I give it large enough b. But otherwise, in that area there is no solution to that formula is ever equal to 0 because it doesn't hit the y equals 0 axis. Okay, enough practice with the quadratic formula. And we can give you more if you're at all had any problem with these. I'd call them fairly simple, but they give you a negative number in that square root. No reason to panic when you see a negative number under the square root. That just means there is no real solution. Just solve square root of -1 is I, and you're good. I don't think they're going to be giving you a lot of these. They may give you 1 or 2 saying, is it a real solution? That's more likely the question you're going to get on a test. But you're ready to actually know write out what the answer is. And it'll most likely be, well, I don't know if they give you a fill in the blank or multiple choice to fill out. Does it have that I in there? So that's the usefulness of looking at the discriminant first. You'll know whether you're going to have a I in the solution if that discriminant ever turns out to be less than zero, less than zero, a negative number. And remember the song, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, little break here while I get the section 2.5 and we'll start working through that. And GeoGebra comes in pretty handy here too. So as we think of parabolas now, so section 2.2, sorry, 2.5. And let's open it up. Not in that, let's go back to that. 2.5, let's take a look at section 2.5. And we're going to open that with Edge, because Edge lets me edit it with my little stylus. I think after, well, just using GeoGebra to look at that ax squared plus bx plus c, that has helped you, I think, if you think about that carefully, that has helped you actually understand this. And this, I think, will come out easier for you. Let me zoom in just a bit there. It's always going to be a cup-shaped curve, either up or down. And what determines if it's going up or down? That thing multiplying, the thing multiplying the a. Remember how